Alright everyone, so we are going to cover lesson 1.2 today, which is modeling quantities. And in this lesson we're going to talk about how we can use rates, ratios, and proportions to solve real world problems. So we're going to see a lot of word problems today. Okay, and the vocab we're going to use, we've got ratio. That is a comparison of two numbers by division. So that could be represented in a couple different ways. Okay, it could be represented as 2 to 3. That's a ratio. Or also it could be represented as 2 to 3, like a fraction. Either one of those are ratios that we can see in these word problems. For a proportion is an equation that states that two ratios are equal. So I always tell my students, we start off with blank over blank is equal to blank over blank. This picture here on the side, don't mind it right now, we're going to use it later. But so proportion blank over blank is equal to blank over blank. Give you some examples. Maybe 2 over 4 is equal to x over 10. Okay, something like that could be a proportion. A scale is something that we see on a map a lot. So you think about a map, you could look at the whole map of the US on a little sheet of paper because it's scaled down, right? Obviously it's not as big as the whole US, it's scaled down. So we see scales a lot of times on maps. Maybe it'll say like 1,000 miles is equal to 1 inch. That's saying that 1,000 miles of the earth is equal to only 1 inch on the map. That's what we're talking about when we talk about a scale. So I think a lot about maps there. Okay, a rate is a comparison of two quantities with different units. This one, there is a lot of these in the world. The first one that comes to my mind is 12 inches are in 1 foot. It's the one that always comes to my mind, but there are tons of these. That's just one rate. And a conversion factor is the ratio of two equal quantities, each measured in a different unit. Ratio of two equal quantities, each measured in a different unit. So that could be something, actually it's really the same thing as a rate, but a conversion factor is always true. Its carries are always true ones, so I'll give you another example. 3 feet is in 1 yard. Okay? Sometimes when we look at rates, they can have things like variables. So it could say x miles is equal to 200 feet. Okay, something like that. So in a conversion factor, it's always true. It's going to have both numbers. In a rate, it could have a variable. Alright, so I've given you guys examples of all of these vocab, but what I want you to do now is I want you to, once you get all these down, I do want you to pause the video so that we don't move on yet. I want you to pause the video. On the left-hand side, I want you to give me an example of each one of these. So I want you on the left-hand side, so it's something you're doing, not I'm doing. You're going to write ratio, give me an example. You're going to write proportion, give me an example. Scale, give me an example, and so on. Okay, so not the same example I gave you. I already gave you these, you need to give me your own. So pause the video and do that. Alright, if you are back with me, I'm assuming that you have already given examples of all of these vocab on the left-hand side. So we got 4 different sections of this unit we're going to go through. The first thing that we're going to do is we're going to use proportions to solve equations. So use proportions to solve equations. So that's going to be kind of our first subtitle. Alright, and this is a little drawing I drew out just so I didn't have to do it right now in the middle of the video. So we've got the sun here, and the sun is giving off its rays, right? And it's hitting this building. It's also hitting this man. And it's hitting him at the exact same angle. And these are their shadows. I know I'm a beautiful artist, you don't have to tell me, but these are their shadows. We're assuming everything's perfect in this picture. And we're going to look at, I'm just going to put out their shadows here. They're at the exact same angle. So they're similar right triangles. All right, let's look at some heights. So here we are going to have 800 feet. You know what? We'll do a small, we won't do a skyscraper. We'll just do a building. 80 feet. We're going to have the shadow is going to be 25 feet. The person's height is going to be 6 feet. And we're going to see what is this shadow. You can call it any variable you want. I always stick with my trusty x. So I'm going to call it x. What is that variable? Anytime that you have a picture like this where you're only missing one thing and you have similar objects, similar right triangles, we're going to use proportions. And if we look back at our vocab proportion, you can remember it's blank over blank is equal to blank over blank. Some people don't know how to fill in these blanks, right? We have 4 things here that we've got to fill in, but there is a right way to fill them in and a wrong way to fill them in. So how I always do it is I kind of categorize my fractions. So I'm going to make just a little chart almost to figure out what's going in my numerators of my fractions and what's going in my denominator. Okay, so I'm going to make a little chart, and we are going to put the things that this problem is talking about, the things that it's talking about over here on this left side. So the things here are the building and the person. So we've got the building and we've got the person. Okay, those are going to be for my rows. For my columns, what do we know about those things? So what about those things? What about those things? Okay, and what are we talking about with these things? So the 2 numbers, the 2 numerical values we know are the height and the shadow. So this column's going to be our height, and this column's going to be our shadow. Okay. So when we are filling in each box, right, we have box 1, box 2, box 3, and box 4. I'm labeling them just for us to get through this. In box 1, we're going to put the building's height. It's right there. That's the building's height, which is 80 feet. Since all of them are in feet, I'm not going to include the units. Okay, in this box here, we're going to have the person's height. That's 6 feet. Remember, I'm not including the units here. In box 3, that is the building's shadow, which is 25. And in the last box, we have the person's shadow, which is x. Alright? And so let's see kind of what equation we've got going on here. I set up this whole table just to make it easier for us, make sure we didn't make mistakes. But now let's see what problem we're actually working with. So we've got 80 over 6, right? 80 over 6 is equal to 25 over x. Awesome. Okay? And we are going to cross multiply something. Last year I had students call it the butterfly. I liked it. So we're going to cross multiply. Move the numbers across from each other. And the numbers across from each other. We're going to multiply those together. So I'll show you how that works out. We get 80 times x. 80 times x is equal to 25 times 6. Okay, so I'm going to do 25 times 6. And I'm going to get 150 is equal to 80x. And in order to solve for this, we learned last time about inverse operations. This is multiplication. The opposite of multiplication, the inverse of that is division. So we divide both sides by 80. Okay, 80 divided by 80, that's just 1x, is equal to, and then 150 divided by 80, we get 1.875. So x is equal to 1.875. Not quite done because we don't have our units in there. But if we go back to our original picture, our units are feet, feet, feet. So we've got feet. Okay, so x is equal to 1.875 feet. That means that this shadow here is 1.875 feet. If you, I'm just going to show this for those of you who who like to do everything by hand. Maybe you didn't want to divide it and get a decimal, you just wanted to simplify the fraction. Just going to be a little review of simplifying. 150 divided by 80. I noticed that 10 would divide into both of them, so I divide it by 10 over 10, which gives me 15 over 8. And I don't think from there I can do anything else. So that would be the simplified fraction. Perfectly acceptable answer as well. You could have written x is equal to 15 over 8, and that's, of course, 100% full credit. Perfect. All right, so here is using proportions to solve equations. That's one example that I worked out. I'm going to give you guys one to work on your own. If you don't have this down, just pause the video. I'm going to erase it. Okay. And I'm going to make sure that you guys are all good to go, know what you're doing with proportions. So let's say that the building is y feet high. The shadow is 10, watch it, switch it, we'll go to yards, 10 yards. So the person is 2 yards tall and has a shadow of 1.5 yards. Okay, and you're going to figure out how tall is this building. How tall is this building? So you pause the video, you're working this out on the left-hand side of your notebook, and you are doing proportions just like we did in the last one. So work it out on the left-hand side. Alright, if you're back with me, I'm assuming you have already worked out this proportions problem. I'm going to give you the answer really quick. The answer should be 13 1/3 yards, or 13.33 repeated yards. Okay? Awesome. If you didn't get that, you might want to try it out and rework it again, but we are going to move on to our next problem. Get to erase my lovely drawing. And we're moving on to the second section of these notes. So our second section, we are using scales to solve problems. I'm going to call this number 2, using scales to solve problems. Okay, when it's talking about scales, we talked about a map, right? So we talked about maybe a map of the U.S. So I'm going to draw out our map. And I'm going to say that we're going to travel from, let's say, from New York, New York, all the way over to Australia. Now, let me make it realistic. We'll go California to New York, okay? We can't drive through water at this point. California to New York. And let's assume that we are making a straight path from California to New York. Straight path. Okay, so let's just pretend that freeways were actually made how they should be made and that it's a straight path there. And we're going to have a scale on this map, right? It's not going to be realistic. We can't just measure and say, oh, we only have to travel 5 inches to get to New York. It doesn't work that way. We're going to have a scale. 1 inch, every inch on this map is going to equal to 100 miles. Okay? Every inch is going to equal to 100 miles. So if you go on this map and you measure the distance between California and New York, so you're going to go in with the ruler and measure the distance, and you're going to say, okay, it's about 5 inches. So 5 inches. Okay, that's how much you measured. Is equal to measured distance. We still can use a format of the proportion if that helps you out, but we are going to see